We're measuring the AI cyber capability, and UK AISI ran this, and then, as we just said, did a blog post after because they already had released Mythos preview. So what we're going to cover, just the headline findings up front, why this matters now, what are the eval gap that they built against, the two big findings with the figures, and then what changed in April that they had to do the blog post follow-up, and then the trade-off and limitations. So top level findings are CTF has captured the flag. So for people who don't know cybersecurity, that's some basic competitions, or sometimes there are competitions where different teams, red teams, will try to gain entry. So say there might be a password stored on a server, and you have to break into the server and return the password in that way, or the keyword, and that proves that you did it. They usually have one server or one device, and not complex. So it's not just a capture the flag score. It's a multi-step autonomous attack. And they built two ranges, range meaning just a full setup that has multiple devices, multiple servers, multiple network components. And so that's a lot more like reality that, say, in a company that attackers would be going against. So their main findings were, one, that it's using that, and then that worked. And then also that the performance scales log linearly. And interestingly, there's no plateau. So you can keep going. If you throw some more money at it, you will get more, you'll be able to break into more complex scenarios. And then each generation extracts more from the same compute. So as we'll see later, sorry for the background noise, but we'll dive into it. Not even in New York this time. That's San Francisco. So Anthropic reported, so there are multiple instances of this happening in real life. Anthropic reported apparently state-sponsored campaign. They've actually had, I think, at least a couple that they've found. One was, I think, fully autonomously, or like 95% autonomous, with the humans being strategic advisors. And the ISIL independently found 12 zero-day vulnerabilities. That is huge, and some of them have been around for decades. 0 days, for people who don't know cyber, also, hopefully everyone does, but that's something that no one else knows about. So you can attack any system because no one's defending against that. So they found 12. I think they were high severity or higher. I don't remember. And then also OpenAI and Google have reported multiple malicious actors trying to use their services. And it's not always easy to discriminate which ones are valid. Perhaps you'd have a defender, blue team, which can look quite similar, or a red team where you're purposely trying to, but you're with the company and you're trying to make it stronger. So it's hard to differentiate. So as we said before, the capture the flag puzzles, they're useful, but they're usually a single skill against a single host. Most real incidents, I've been a chief technology officer for years and served at times briefly as a chief information security officer, CISO. And what usually happens is you get a foothold, even perhaps on a user's laptop or something, and then you're able to grab some more credentials and shift over horizontally to another, maybe a server, and escalate such. So none of this was captured in simple capture the flag, though that's most of the evals have been like that, just like most of the capability and evaluation awareness and other evals are single turn, and it's much more complex to do multi-turn and even more complex to do multi-agent. So Sci-Bench, which is one of the standard, is 93% solved. Again, something that we see in other evaluations, there's saturation. So we can no longer tell how far they're going. So real attack chains, as we've already said, go for more than that. So the two ranges, one was TLO, which you'll see again and again. So that's just called the last ones, and one's called cooling tower. The last one's where they did most of the work, and that's supposed to simulate a corporate network attack. It takes an expert usually around 14 hours um, if they're working unaided. And then with these, we just had the models working unaided. And the number of steps, that's how many they thought that it would take. But as we'll see later, at least once one of the models was able to bypass and do a simpler way or a way that it was better at and skipped, I think, 4 steps or so. The cooling tower is an industrial control system like cooling towers. And that actually, interestingly, stymied the models a little bit more. So the standard React, which means reason, act, and observe. This is the stack, different tools, Mythic for command and control framework, and up to 100 million tokens per attempt. And then the same harness. A lot of evals, especially over time, use slightly different harnesses. So obviously we want to have the same situation so that we can get the most comparable numbers. So remember the last one attack. I just to make this tangible, especially if someone hadn't gone and looked at the paper, this is just the bottom part so we could actually see it. These are some of the steps that it would have to go to. So you can see here, hard hat, go hit an API, go into an orchestrator, get to a workstation, etc. So very complex attacks. It's not just plodding along, solving one problem, then another. And then the methodology. So I've got 7 models we went through, from August 2024 through February of this year, and compute budgets 100 million and 10 million, and 5 to 15 runs per condition. And this will skip. So the threat model. The skilled attacker will write the chain, and the skill is the real bottleneck. When I think it was Opus 4.5 came out, or before it came out, and Anthropic was doing testing, they had found a number of zero-day vulnerabilities, and then with 4.6 even more, and then Mythos Preview just a huge number. And often using tools, you have a scaffolding where you say, okay, this is how you should work, etc. When Opus, I think it was 4.6 and 4.5 came out, they just said, I don't remember, they never released the words, but it was no special instructions. It's like, go find vulnerabilities pretty much. So that was extraordinary. It's not that they were used as a tool with some special guidance. It's go do these things. So what does this mean? If you have money, you can buy more capability. That's dangerous. There's only so many cybersecurity engineers in the world. They're a large number, but there's not infinite. So you actually would have to, as a state actor or anybody trying to do some damage, would have to get a large number of these people so that you could broadly attack a lot. Here, money turns into vulnerabilities and compromise, and not a large amount of money either. So each generation does more per token. And you can see this here with 10 mil tokens, get about 5.8 times every 1.5 years. And then with Opus 4.5, to Opus 4.6, you got 42% jump in 2 months. And that's not even counting in Mythos preview. So what did not help? Um, One, adding the 2 sentence of high level guidance didn't actually help much. That's what we were talking about before. And that definitely did help and was absolutely necessary in some earlier models, not exactly the ones preceding it. So it was highly noted when it came that not even giving any guidance would help. Also, pre-filling the message history with some of the attack chain one would think would help, wasn't needed, didn't really help. And then system prompt instructions also didn't help. So the Opus 4.6, its single best run on the last ones, the corporate network, completed 22 of 32 steps. And then 3 weeks later, obviously they're different base models and such, but 3 weeks later, the pre-released Mythos preview averaged 22 steps out of 32 across 10 attempts in the same range. Yeah, this was, I think, $80. I didn't do the math. Oops. But I think the maximum for any of these was about $500 if I remember correctly. So it's very dramatic. We can just go this. And so the cooling tower model, the best model was Opus 4.6 and averaged only 1.4 out of 7 steps at the 100 million token level. I think I found some research that were trying to do more than that, but I couldn't find data on that. But it was definitely continuing and hadn't plateaued. So interestingly, they brute forced. This was one of the steps where they humans thought that it would have to go through this specific kill chain, but they actually bypassed it. So instead of doing some complex um, reverse engineering, I think it was Windows Server to find out cryptographic keys um, and then get in through compromising passwords that way. They brute forced the session values using this protocol. They basically put a bunch of not quite well formed protocols into the network, and then they just watched how the devices responded, and they were able to deduce how to abuse it and found 0 days attacks just by essentially yelling random things at it. Um, this is interesting and very surprising. We'll see later in some notes about why this type of attack would be found, basically. But it still shows that there's a lot of capabilities that we just wouldn't even think about doing. Sorry about this. I had some issues with some of the slides, but so so one thing that they did, so there's a trade-off between um, hiding and keeping confidential the examples. Plus sides of that is it allows them to be useful for longer. They're more durable because once they're out in the public domain, either by accident, they can become part of a corpus, or you can have misaligned models going and trying to be very helpful by going and finding the answers and then using them. Or you can also have misaligned companies, which are model makers who really want to ace the scores. So they go out and, overtune, overfit on maxing out some of the capabilities or benchmarks. So those are the good side, but the downside also of publishing your materials. So they decide to do this. That I'm not sure how long we can consider that they would be valid for. I would guess maybe one or two model revs, which means a month or two. Um, but I didn't read in depth, but we'll have to have ways of auto-generating these kind of so that we can go across different, still have some way of evaluating. And then limitation of the papers, there were no active defenders. So usually two things. One, you'll be detecting. You won't have perfect detection, but you always at a corporate network have some type of detection looking for, at the very least, multiple login attempts that fail, or emails that look weird, or new devices that appear that usually aren't there, all sorts of things. Or even just high processor utilization, something like this. Um, and in some types of games, you have, say, a blue team who's acting as defenders and red team who are trying to get through. They get penalized if they have if they're detected in some way. They still might be able to evade and go another way if they're detected, but you get some penalization, which is like real life because if if the target knows that they're being attacked, they could shut down completely. They could take extra steps, which would be the active defense. Um, so a future, which they called out, future systems would have the detection and then some type of active defense, which could also be models who are doing this. And what are the implications? Most relevant is the threat, and that it's not doesn't have full autonomy in these instances. There was the almost full autonomy that attack from the state actor that Anthropic found, but usually it greatly assisted. But the most dangerous is a model with human to help it get past a few points, and also that accelerated it a lot faster. So you could, for the same amount of money, if you have one or more security engineers helping, you could hit a lot more targets for the same money, even paying for that person. Um, Cyber defense is dual use, can help defenders and help attackers. I don't know of a similar paper, which there should be, where you have the model be the defender and having multiple attackers come at it. But we should be doing that as well. Um, Doing that in real life with Mythos preview and such. And we already talked about evaluations, harden, defend, and monitor environments. So look forward to the Q&A. And this is multi-step and it's longitudinal, which is great. I'll be interested to see if they do ChatGPT 5.5 Cyber, which was released after the blog post update. I think they said that they're going to keep up with them, at least for some time. And then compute scales capacity. So that's the biggest thing. I don't think it even was looking asymptotic. As long as you're on the log scale, it was continuing to go up. And then we've already talked to that. So that is the end of the presentation.